Hello and welcome to the video. In this video, I'm going to tell you about the new features for MagiCAD 2025 main release for Revit and for AutoCAD. This video will be divided into two parts. In the first part, we'll go through the MagiCAD for Revit, and in the second part, through the MagiCAD for AutoCAD. Below, you'll find the time codes with which you can easily navigate through the features. Let's get started, and first we'll go through Revit. MagiCAD 2025 is compatible with the new Autodesk Revit 2025, as well as with the previous two Revit versions 2023.1 and 2024. MagiCAD has also been upgraded to .NET 8 framework to keep the latest compatibilities with Revit. MagiCAD 2025 also supports Revit Dark Mode, and the visuals for command icons have been updated to better and more visible look. MagiCAD can now calculate dry sprinkler systems where part of the piping system is filled with air or gas. Let's create the dry sprinkler system, and for this, let's install the sprinklers. Let's go to MagiCAD Piping, tab to Install Product, and then here you can choose the necessary sprinklers. I'll choose this dry sprinkler option, but you also can choose a usual sprinkler. Okay, let's choose this one. But before we install this, let's define the orifice size. It's the necessary condition for dry sprinkler calculation. Okay, then I'm clicking OK. Let's select the sprinkler. And here you can define the system. You actually can add the new system, but I won't do this because I'm satisfied with this dry sprinkler system. Also, let's change the area of coverage, for example, to 10 square meters. And also you can choose some other options here. Then I'm going to draw the line like this. I installed the sprinklers. Then let's click Apply and apply one more time. And right now, let's draw the pipe. I'll create a similar of this pipe. And then I'm drawing like this. And then I go back to MagiCAD Piping tab and to Sprinkler Connection. Let's choose this type of connection, inline connection. I'm choosing all sprinklers, clicking Finish, and then I'm choosing the pipe. Good. Let's click OK. Then the second thing that we should make for dry sprinkler calculation is dry valve installation. Let's go to Install Product, to Piping. Then you can go to Other Valve, and then you can choose the valve and change the valve type to dry valve type. I'm choosing this special valve for dry sprinklers. And also I'm assigning the dry valve type. Let's click OK and let's select it. Here in the dry valve data, you can assign the necessary settings, such as opening pressure ratio, whether valve has accelerator or no, then the accelerator delay, and activation pressure drop. Okay, and I'm going to install this valve here. Apply, and let's close the window. I'm going to move it a little bit up, like this. Also, you should install the pump to the system. it's already installed, and then we should define the design area. In general, the actual network and the design area are defined in a similar manner as the existing wet networks. All functions designed for wet networks work exactly in a similar manner in the dry sprinkler networks. For design area installation, I'll go to MagiCAD Piping tab, then to Calculation Control, and then I'm choosing the sprinkler design area. I'm assigning the system, dry sprinkler system. Then I'm typing the height levels. The bottom will be 0 and the top will be 3000 millimeters. And then let's give the name to this design area. For example, it can be dry 1. Then let's click OK. Let's just place on work plane. And I'm drawing the design area like this. And after that, we are ready to perform the dry sprinkler calculations. Let's go to MagiCAD Piping tab, then to Calculation, Dry Sprinkler Calculation, and then let's choose Dry Sprinkler System. So here you can choose the water source pressure and also the pump pressure. I'll use the pump pressure. Then you can choose the gas that will be used in the dry part of the network. You can choose between air and nitrogen. I'll choose air, and let's perform the calculations. Okay, I received this warning. It is said that I should try to recalculate with shorter time step. Okay, let's make it. Let's go back to calculation, and then let's just dry sprinkler calculation again. And after this, I'm choosing this time step in calculation. Then let's click OK. And now the calculation is ready. So here you can see the information about the dry sprinkler area. Also you can see the sprinkler results, system results, and also pipe diagram. Let's click OK, update to model, and the calculation is done. The Project Wizard tool now allows you to create spaces based on a linked IFC reference file. For this, let's go to MagiCAD Common, then to Project Wizard, and then move to Spaces. Then go to the Copy from Link option, and here you can choose the IFC model. Also, you can add some parameters. And then you can copy the spaces. Let's copy. Okay. 66 new spaces were added. Since the quality and conversion of the IFC file in Revit can cause issues if only creating spaces with the IFC geometry, the tool will create the space outlines for better ending result. Go to MagiCAD Command, then to Clash Settings. And because project might be heavy to use when real-time clash is active. To help the performance issue of collision check, MagiCAD now contains view filtering for the real-time clash checking. So here you can see the view selection option, and you can choose the views where the collision should be checked. Then click OK. Of course, choose the categories, and then you can run clash checking only for the necessary views. While designing duct and pipe networks, sizes of segments can be easily changed, but such changes leave some components, for example flow dampers and valve, unchanged. So let's go to MagiCAD Ventilation, then to Install Product, and I'm going to install a flow damper, for example this one. Let's click Select, and then I'm going to log the size, and let's install the fire damper with the locked size here, and with unlocked size here. Then let's click apply. Let's close the window. And after that, let's change the diameter of these ducts. For example, it can be 400 millimeters. And as you can see, the size of the flow dampers remains the same. But with the component sizing option that is located under calculation, you can change the size. Let's select elements and then the object. And as you can see, the fire damper was resized. And let's go to component sizing again. And then if I choose unlock component dimensions automatically option, even the fire damper with the locked size was resized. In contrast to sizing calculation tools, this tool can be used to parts of the networks which have multiple open ends or designing is otherwise in progress. Size of components is selected based on the attached segment size. System classification codes can now be added for electrical systems, including communication and data systems. Let's go to MagiCAD Electrical, then to Modify Dataset, and then under Electrical, you can find the systems, and then double clicking, and you'll see that you can assign the system classification code. Also, the same action is for communication and data system. System classification codes can be added to all the project and existing object without codes with the update parameters function. Update parameters function is located under MagiCAD Command tab here. And under electrical, you can check the system classification code. And then if you assign the system classification codes in the dataset, the parameter values are filled for system objects during system drawing. Let's go to MagiCAD Electrical, then let's choose cable tray, for example. Then I'm going to the options and I'm choosing the emergency lighting system because I assigned the system classification code for it. Then let's choose this cable tray. Let's click OK, and then I'm drawing the segment. And then if you go to the properties, you'll see the system classification code. Installing angled products has gotten more efficient due to the new Smart Installation options. Smart Installation lets the user to select 90-degree bend and replace it with angled product, which makes the installation more fluent. So I have here the shower mixer. Let's draw the pipes. And then I'm going to draw the riser. So for example, from 200 millimeters, then to 2000 millimeters. Let's click OK, and let's make the same action with the cold water. I'm drawing the pipe, and then I'm installing the riser. Nice, and then I'm going to go to a 3D section box. And then, if you go to Install Product option, to piping, you can choose Other Component and Stop Valve for replacing 90-degree bend. I'll go to the Other Component, and I'm choosing this wall box. Let's select it, and then I'm choosing the bend here and here. Let's click Apply. And then we can use the alignment option. And it looks like this. The angle to horizontal has been improved to work with sloped pipes. So here I have the sloped pipe. Then let's go to MagiCAD piping, then to angle to horizontal, and then let's choose the end of the pipe. And after this you can choose the angle, and let's also change the elevation. For example, the pipe will go downwards to the elevation of 0 millimeters. Then let's click OK. Escape, and after that you'll see that the pipe went downwards. And also you can make the riser. It will be 87-90 degree if pipe is sloped. Then let's change the elevation to 500 millimeters, and then I'm clicking OK. And let's go to the 3D view, and then you'll see the riser here. It's now possible to ignore sound attenuation in distribution boxes when performing design flow sound calculation. Let's go to MagiCAD Ventilation tab, then to Calculation, and to Sound Calculation, Design Flow. And here you can choose the option Ignore Sound Attenuation in the distribution boxes. So I'm choosing the system with the distribution box. I'm clicking OK. And then if we take this distribution box, you'll see that the attenuation was ignored. In sprinkle calculation, there has been improvements in saving of the input values of sprinkle calculation options dialog, including water source, pressure diagram. Let's go to MagiCAD piping, then to calculation, then to sprinkler calculation. I'm choosing the system. And after this, let's put the values to the water source diagram. For this, I'm going to balance into minimum pressure, like this. So, for example, value will be the following. And like this. And right now, when you are clicking OK, let's cancel the window. And if we go to sprinkle calculation again, after clicking OK, you'll see that the water source pressure diagram was saved. Previously, input values were lost unless the user clicks Update to Model in the report. Radiator valve adjustment information is stored as a radiator parameter. So I have a valve, and here you can see the MC adjustment value. And right now, let's perform the heating cooling balancing calculation. I'm clicking at the system. And then let's update this calculation to the model. And then if you click at the radiator, you'll see that the MC adjustment value also is assigned to the radiator. This prevents need for separate tags for the radiator and the radiator valve. In heating cooling balancing calculation supply pipe, water flow temperature is added to the calculation report. So let's perform the heating cooling balancing calculation. Then you'll see the temperature value. It's available only for the supply pipes. Let's update to model. And then if you click the supply pipe, you'll see the temperature value. In sewer flow calculation, maximum nominal flow from a single device upstream is added to drainage pipes. So Let's go to the properties of the sink, and we'll see that the piping flow equals to 0.3 liters per second. And right now, if we perform the drainage flow calculation, for this go to MagiCAD piping type, and then under the calculation you can choose this type of the calculation. Let's calculate the whole network and let's update to the model. And after this, if you choose the pipe, you'll see the MC piping maximum drainage flow value. Pressure drop calculations for duct bands with guide vanes has been improved. If there are more than 3 guide vanes in a band, warning is shown in the report due to lacking measurement data for such bands, and calculation uses data from the case of 3 guide vanes. So I have different bands. For example, this one, it has 5 vanes. This one has 0 vanes, 3 and 5 accordingly. And let's go to ventilation and let's perform the pressure drop calculation. Let's click OK. And then, as you can see, there is a warning. Let's show the warnings, and it says that number of guide vanes more than 3 are calculated as if there are 3 guide vanes. Updating product code instance parameter with update parameters was very time consuming earlier. Let's go to MagiCAD Common, then to update parameters. Performance has been improved significantly when product code instance is selected. Most noticeable difference is within piping discipline. So let's go to the piping, and here you can find product code parameter that you can update. MagiCAD 2025 is compatible with the new Autodesk AutoCAD 2025 as well as with the previous 4 AutoCAD versions 2025, 2022, 2023, 2024, including the verticals AutoCAD MAP and AutoCAD Architecture. You can now easily search for more information about a specific MagiCAD function during design work. Simply hover over a feature button and press the F1 key. For example, let's choose the sprinklers and then F1 button, and then the corresponding section in the MagiCAD Help manual will be opened. Now we can import IFC files from DIALux Ever project to MagiCAD projects. For this, you should go to MagiCAD Electrical, then to DIALux Import. After that, you should choose the file that you'd like to import. So, for example, test file. Let's open it. Let's choose the floor that we would like to import. Then let's click OK. And after this, you can choose the installation, also the system, and then you can map the product to the corresponding one in MagiCAD. So I will always choose this product in MagiCAD, just for example. Then let's click OK Import. And then I'm going to choose the location. And that's it. Also, luminaries are automatically mapped to luminary type in MagiCAD when their manufacturer names and article numbers match. And also, let's go to the DIALux Expert again. Let's choose the file. Okay. And here you can update placement of existing instances instead of creating an entirely new design each time. Busbar trunking systems are now supported also in short circuit and voltage drop calculations. Let's go to the MagiCAD Electrical, then to Technical, and then to the voltage drops. And then I'm going to choose this transformer as a switchboard. And as you can see, the calculation is done. And then we can update this data to the drawings. But also short circuits calculation is available too. Like this. Also, the modeling of busbar systems has been made easier with the help of default branch length. To assign the default branch length, go to Project, then to Electrical and to the busbars, and here you can assign the default branch length. For example, it can be 1K millimeters. Let's click OK. Good. And then let's draw the busbar trunking systems. Okay. Here, and right now it's 1000 millimeters here. And then I also can go to Options, to the Properties, and let's change it to 100 millimeters. Then let's click OK. And then let's draw. And now it became 100 millimeters. Also, all editing functions have been improved and stabilized for more reliable and intuitive performance. For example, if we go to change fitting length, and we'll change the fitting length to 500 millimeters, the workflow became easier. Let's create the bus circuit, and for this let's go to the bus connections, and then let's add the host. For example, this switchboard. Good. Then let's add circuit. First of all, I'm going to add the circuit 1, and let's add devices to this circuit. I'll manually choose the devices like this. And right now devices appeared in the circuit. And right now it's possible to zoom to multiple devices from bus connection settings dialog. For example, I'd like to zoom this object. This luminaire is zoomed and the device will be marked with a cross. Also, you can zoom multiple objects. Also, let's create the circuit number 2. Okay, and let's add devices. And right now, if you are trying to add the devices that belong to another circuit, like this, you will receive the warning. And there are two options, whether these objects should be added to the new circuit or to remain in the current circuit. For example, let's skip such objects. And as you can see, no devices appeared. And also bus host and bus circuit can now be added to object ID format definition to automatically make unique identifiers to device. Let's click OK, and then let's go to the project, to variable sets, to object ID, and then if you choose the object ID formats, you'll see the bus circuit and bus host in the list. The machine learning underfloor heating algorithm has been improved to better take different shapes of the room into account, cold walls, and provide a better overall layout of the pipes. Let's go to MagiCAD Ventilation and Piping tab. Then I'd like to choose Out-routing underfloor heating option. And here you have different settings. You can point inside room, you can select polyline, or you can choose different points. but in this case I'd like to choose polyline, and then you can select up to 2 cold walls. You can choose 1 cold wall and then just press enter, but I'd like to choose 2 cold walls. And then you also should point the inlet position. For example, it can be here. Then let's click enter, and then you can run simulations with these settings. And then MagiCAD offers you different results for the underfloor heating layout. For example, I'm satisfied with the option 3. Then let's click OK. And underfloor heating appeared. But also, let's make the underfloor heating in this office room. And then I'll choose the point inside the room. And I should also choose the inlet position. It can be somewhere here, like this. And as you can see, the cold wall is automatically assigned because the information about spaces is taken from the MagiCAD Room. And you also can run the simulation according to these settings. And then you can click OK. You can now add national classification codes for various generic objects that are not part of the MagiCAD project file, such as generic manifolds in ventilation and piping projects. Let's go to piping component, and then let's choose manifold. And then here you can choose the national classification code. OK. And then if you go to the properties, you'll see it here. In electrical projects, you can assign the national classification code to the switchboards. Let's go to switchboards. And you can assign the national classification code from here. And also it's possible to set national classification codes in the project file for provision for builders' work openings and segment fittings. Let's go to the project. Then to provision for builders' work openings, let's go to the settings. And in the settings here, you can assign the national classification code. And if you go to the ventilation or to the piping, to the parts, to the fittings, for example, to the vent, you also can assign the national classification code here. The calculation of dry sprinkler systems is now supported. Let's go to the sprinklers and let's install, for example, this sprinkler. Let's assign the system, and here you can also set different options such as area of coverage, pressured sprinkler, orifice size. Pay attention please, this setting is really important for the dry sprinkler systems calculation, then the flow density and the pressure at the sprinkler that is taken from the flow density. Okay, let's click OK and let's install the sprinklers. Let's choose the installation level. Let's click OK. And I'm just installing the sprinklers like this. And now let's choose the sprinkler connection option. I'm going to choose inline connection. Let's click OK. Then let's choose the sprinklers and the pipe. Nice. Now it's connected. And the next step for the dry sprinkler systems calculation is the installation of the dry valve. So you can choose every valve from the other valves, but it should be dry. For this, you should go to the project, choose the valve that you'd like to install, and then assign the valve type. And choose the dry valve as the valve type. Let's click OK and close the window. And right now we are ready for the valve installation. I'm going to choose this one. Then let's click OK. And let's install it. And then we should define the sprinkler design area. Let's give the name, dry, assign the system, and also choose the depth of area. Let's click OK, and then you should choose the points. And click Enter. And right now, everything is ready for the dry sprinkler systems calculation. But don't forget to install the pump to the project. Okay, let's go to the technical. Then to calculate dry sprinkler network, let's choose the system. Okay, let's choose the sprinkler design area. Also, you can choose the gas. It can be air or nitrogen. I'm choosing the air. Then you can assign some settings such as temperature, initial gas pressure, time step calculation, and warning limit for delivery time. Then let's click OK, and the calculation is done. Here you can see some information about the dry sprinkler area. Also here. Then you can see the sprinkler results, the system results, the equivalent length values, and the pipe diagram. Let's click OK and update to the model. The calculation is ready. You can now define label attributes to be updated from switchboard schematic. So I have the switchboard schematics here. And if I go to the MagiCAD switchboard schematics, and then I click Edit, Edit Circuit. Let's edit, for example, this circuit. You will see different properties, such as active power, description, for example. So then I created the circuit schematics for these two circuits, and they're here. And right now let's go to MagiCAD Circuit Designer, then to the drawing settings, and here let's change the content. You have user-defined value, but also the value from the switchboard schematics. For example, I'd like to take the active power. The attribute name will be content1, like this. Let's click OK. And after that, let's go to Update. Update from switchboard schematic. And then you'll see that the active power appeared in the sheet. Let's go to MagiCAD Room, and then let's go to the properties of the meeting room, and then to heat loss analysis. Thermal bridges have now been added to the calculations in MagiCAD Room, which means that additional heat losses from corners of the room or around windows and doors can be considered. Let's, for example, take a look at the junction between two outer walls pointing outwards, and you'll see the thermal bridges that will be calculated. The calculations can be done according to the National Building Code of Finland, or by using a set percentage of the existing heat losses as an approximate value for the thermal bridge heat loss. So you can assign the thermal conductivity here to calculate the heat losses. But also you can calculate total thermal bridge value as a percentage of surface and airflow heat losses. For example, if we take 15%, then the total heat loss will be 1798. But if it will be 40%, the value will be bigger,